Good morning, friends. So, in this video lecture, we are going to discuss about major components of nuclear power plant. As you know that all the power plants contain some common components which are mandatory for any power plant, considering the safety and work output ratio and location and other criteria. So, this video will depict the important components and their functions in brief manner. Since this is the nuclear reactor, which is the heart of nuclear power plant, as we have boiler in coal-based thermal power plant and a diesel engine in diesel power plant, gas turbine in gas turbine power plant. In similar way, for nuclear power plant, nuclear reactor is the heart of the nuclear power plant. Since inside the nuclear reactor only the combustion, that is reaction, is going to take place and heat energy will be released and the same will be utilized for steam generation. So look at this picture. Here we are seeing the cut sectional view of animated nuclear reactor. How safety measures have been implemented while designing the nuclear reactor, that is very important. Since in day-to-day life, whenever we are trying to install nuclear power plant, the people in that area are very much worried the safety about the nuclear reactor. Being engineers, we should know what are the safety measures being taken for construction of nuclear reactor itself. See how many walls they have mounted over the reactor core, that is fuel rod, or surrounding the fuel rod, how many layers of protection shields are built. See, for example, let me give this. This is the containment vessel, 1.5 inch thick steel. This one. Here they are showing that the steel, thickness of the steel which is being used to cover, like a cylinder, like a cylinder cover, it will be inserted over the fuel rod core. 1.5 inch thickness. Normally we may come across thickness of 6 mm, that is 0.25 inches. But here 1.5 inch thickness means nearly 3 centimeter. 3.5, around 4 centimeter thickness of steel wall. Over that, another shield wall of 3 foot thickness, reinforced concrete. In houses for roof, we are putting 4 inch thickness reinforced concrete. Here they are putting 3, that is 36 inches thickness, 9 times the thickness of our house concrete, that is roof concrete. And we have the dry well, 5 foot thickness reinforced concrete. Below that, in the well of the reactor, we have 5 foot, that is 60 inch thickness of the concrete. Concrete means steel structure. Iron rods will be there, and stones and sand, the mixture of the stone sand and other chemicals to prevent any leakage. So that thickness of the wall is nearly 5 foot, that is 60 inches. Our wall thickness in houses is only 9 inch. Now nowadays they are putting only 6 inch wall. Imagine a 60 inch wall. And we have one more shield called bio shield. Look at this. This is a bio shield of thickness of 4 foot, leaded concrete. Lead. You would have heard about the lead. It is a very costlier. Still, they are going for 4 foot. That is 48 inches. Lead concrete with 1.5 inch thick steel lining inside and out, like hybrid integrated steel and lead. Lead itself very high protection shield of thickness 48 inch thickness of lead, and inside that only we have the reactor vessel That too, the vessel is made up of 8-inch thick steel. Our vessels, if you take a cooker, for example, if you take a rice cooker, the thickness of the rice cooker wall is maybe 0.25 inches. Whereas here they are putting 8 inches. Imagine the thickness of the, if you put a rice cooker for 8-inch thickness, how it will be. Imagine that much thickness they are putting. That is called reactor vessel. All those things will be covering the reactor fuel. And 1.5 inch, that wear wall is made up of 1.5 concrete. So many layers over the fuel rod where the combustion is taking place, enormous heat energy is released. So this safety is engineered into the reactor design, that we have to clearly understand. This is the point we want to share here. 1, 2, 3, 4, 5, 6 walls are there. 6 concentric circles. Imagine 6 concentric circles over the fuel rod of different thicknesses. Crores of rupees they are spending for safety measures. Let me briefly discuss what are the things we have seen here. Nuclear reactor, where the chain reaction is taking place. In the previous slide we have seen, when slow neutron bombarded with the nucleus of the uranium-235, it will undergo sustainable reaction. That is, it will undergo release of slow neutrons, 2 to 3 slow neutrons. Each slow neutrons will release another 2 to 3 neutrons. Likewise, it will go in thousands of release of neutrons. Whenever neutron is released, heat energy is released. The control rods, okay. The reaction is taking place due to some reason. We want to switch off the reaction. For that, we will be inserting the control rod, which will absorb the neutrons. When the chain reaction releases the slow neutrons, that neutrons we have to absorb the neutrons. For that, we will be inserting the bundles that is made up of boron, cadmium, or indium. The control rods are made of boron, cadmium, or indium. This will absorb the neutrons and slow down the chain reaction. Steam generator, as you know, it is a heat exchanger. Steam turbine is where the superheated steam will impinge on the turbine blades, and it will make the turbine blades to rotate, so that turbine shaft will rotate. In turn, it is connected to the generator. We are getting the power. For carrying the steam, they are using high performance alloys and super alloys. Since we are carrying at high pressure, so it has to withstand high pressure and high temperature. So we will be choosing the alloys, super alloys, that will be used for carrying the steam from steam generator to turbine inlet. Coolant pump, it is another mandatory. It will supply the coolant water at a pressure of 155 bar. For this, we have the pump and pressurizer. That is the feed pump to feed the water into the reactor. Condenser, when the steam comes out from the steam turbine, it will be condensed by means of circulating the cooling water. The condensate, that the hot liquid, will be again recirculated to the reactor for further heating process. We are not wasting the condensate, it will be recirculated. Cooling tower is used to supply the cooling water to the condenser. When the cooling water and the hot steam gets contact, the hot steam will be condensed and it will become condensate. Advantages of nuclear power plant. The emission from the nuclear power plant is very less. That is, greenhouse gas emission is very less when compared to other types of power plant like coal based or diesel or gas turbine power plants. The technology is being built around the world the latest technology is readily available. We are importing from Russia. The Russian scientists are coming and installing the nuclear power plants along with our Indian engineers, Indian scientists. Indian scientists are also going to abroad in erection of nuclear power plant. So it is proven technology. That is the advantage. Everything has some disadvantage. Here, the disposal of radioactive waste is a challenging one. Where to dispose? Nowadays, also they are talking about Kudunkulam power plant nuclear waste. The governments, both the state and central governments, are thinking about and brainstorming about where to dispose nuclear radioactive disposal. So when we load, it will last for 30 to 60 years. It is a rare, but it will not happen. It may be used by the foreigners, terrorists to